The first topic that we will be discussing is recursion. Afterwards, we will talk about graph and traversal of graph. We'll be discussing about the DFS. Then we'll learn how to implement DFS with iterative method. Afterwards, we'll implement DFS with recursion. So let's start. For this topic, first we'll understand the basic of recursion. Then we'll see where we can apply recursion. Then we'll have a look at the pseudocode and learn the steps in human language. And then we'll implement the code. So recursion. What is recursion? It's basically a programming technique where a function calls itself to solve smaller instances of the same problem. Using this method, we can break a big or a larger problem into simpler or repetitive tasks. And the applications of recursion to make a problem way simpler than it appears to be, also in mathematical computations where repetitions exist. For example, for factorials, to find the Fibonacci series, to find the greatest common divisor. In dynamic programming, we use recursion as well, and also in graph traversal that we will look later. So if we have a look at this picture, we can see that this function and it's calling itself, this is a repetition. But this repetition stops based on a base condition. But we will have a look at that later. In normal cases, how a function works. In this main function, it's doing something. It's called as my function. Then when the function is called, it goes to this function, execute the activities that is supposed to be done by this function, then returns, and then it's continued here. For recursion, the process is a bit different. Almost similar, but in a different way. So this is how recursion works. There we can see two cases. One is the base condition, and another one is the recursive condition. So for the base condition, it gets out of the recursion and returns the base case value. Otherwise, it breaks the problem into a smaller partition. So that is why this is the recursive function, and this is the structure. So we have to keep this in mind that while designing a recursion, we must use a base condition, otherwise the recursion will not end. Now let's see an example and how recursion works. So here we will be taking an input of n and we will print all the numbers from 1 to n. So initially when the function was called, n was equals to 3 because that was the input and that was sent in the recursive function. So here print number is the recursive function. So what it does, it checks the condition. By the way, in this function, this if it's not the base condition. If this condition is false, then it goes to the base condition where it gets out of the recursion or it returns from this function. Now it checks. If num is greater than 0, then it prints the number. Here, 3 will be printed. Then it calls the function recursively, subtracting 1. It goes the next step and here the value would be 2. It checks. If number is greater than 0, which is true here as well, 2 will be printed. Then another call. Here as well, num value is greater than 0, so 1 will be printed. Then it will recursively call after subtracting 1. And in this case, num is 0, so it will not go inside this condition. So here it will return. Next, what will happen? It will return to the previous call, then it will return to the previous call, and then it will return to the first call. And then finally, it will return to the main function. So that's a basic understanding of how recursion works. And we will see another example of how we should apply the base case. For this example, we will find the factorial of n. So what is the factorial of n? It is basically all the product of all the numbers between 1 to n. Here I'm going to take an input of n, and this is the recursive function factorial that will give us the factorial of this number. And here, this if condition is the base case condition that will help this recursion to end. So let's see how this one works. So in the main function, the factorial is called, and initially the value is 3. So it checks if the base case is not met, it will call the recursive function, and here subtraction is done. It goes to the next step, and here the value of n is 2. It checks for the base case, and then if the base case is not met, it calls another one recursively. It goes to the next part. Here the value of n is 1, and for this call the base case is true, so it will return 1 to the previous call. For this call we already have the value of n, and 1 is returned from the other call, so here it will return 2 into 1, 2. That will be returned to the previous call. So it got 2 from the next call, so the result will be 6, and that will be returned and printed. So that's how recursion works, and that's how the calls are being made. And that was all about recursion and the implementation of recursion. We will understand how DFS works, and we will implement DFS using recursion. Thank you so much.